So let me share my screen and we'll get started here. So I'm just grabbing question 11. I hope that's okay. If you want us to do a different one, I can certainly snip that in. Or does the order matter? That's
It
just the
doesn't
first
matter.
one.
That's
Okay.
okay.
All right. So it says here, given angle P equals 10 degrees. So we assume that that one's there. And it says RO bisects angle M to R to P. Now this is not a proof, is that right? Because it's not to, there's no proof. It just says to determine, find, calculate kind of thing.
Right.
Okay, perfect. Now what I would recommend is, and this is a common strategy, is to break apart the triangles into the large triangle and then the smaller triangle. And it's good if they're reasonably close to the actual size. I've had a number of students over the years that they just don't take enough effort to make them kind of look right. I mean, this is not like perfect by any means, but it's clear that that's the big one and that's the smaller one.
Right.
And you label uh you label them as appropriate. So this is 10 degrees, 90 degree matches up. What must be the angle up here in the triangle? What do the three angles in the triangle have to add up to?
80.
Yes. So this is 80. That three angles add up to 180. So you can solve that if you wanted to, but that's very clear. Now, this is where this part about RO bisecting MRP is really important. So MRP is up here. It's bisected. And since the whole thing is 80, those ones in between it are 40 and 40. That corresponds down here to this triangle where this is 40.
Okay.
So why is that important? Well, it's because that's one of the angles we're interested in. This is R, M, and O, and that's ORP. Actually, they don't actually want. So they want ORP, which if you go back to the original, let me snip in the original one again. Sorry, a lot of snips here. Can you see where that one is in the original drawing? ORP.
Yes.
Okay, so that is the one that's up here. That's 40 degrees right there, because it's the same as the other one, which is also 40 degrees. And then you need MOR, which is the one down here on the smaller triangle. So that's also the same. You get it by adding up the three angles in the triangle. So it is 50 degrees.
Got it.
Some small things here. Make sure you put the degree symbol. Make sure you're actually solving for the thing that it asks for. These problems in the book are really good in the sense that they're not as like, they really try to lead you to something. It's not as obvious as say other textbooks where it's like solve for X. They're just telling you to actually find that angle. So any questions on that?
No, got it.
Okay. Let me snip in the next question here. Are your tests normally like free response questions, all worked out by you, the student, or multiple choice?
Yes.
So mostly working them out.
Mm-hmm.
Okay. And does your teacher actually write the test, or is it a common test?
I think he writes them.
He writes them. Okay. Fantastic. So what I would do here is I would take the given information and I would label it in the graph or in the picture and see if anything stands out after getting that down. All right. So to be able to find measure of angle 1, you really need the measure of this other angle inside here. Now, there's a formula for determining the sum of the interior angles. Do you remember that formula? Have you seen this before?
Yes.
Okay, that is the sum of the interior angles. formula. And n represents the number of sides. Now what's nice is it works for a triangle. So in a triangle, you have 3 sides. So 3 minus 2 times 180 equals 180. That's how we figured it out. Now in a quadrilateral like we've got here, sorry, this is not drawn like that. Your n is 4. So it's 4 minus 2 times 180, which is 360. So you definitely want to know this formula. Do you get a notes, like a note sheet or a little card you can bring on the test for anything, or is it all pure memory?
Yes, we get a little paper.
Okay, it might be good to throw this on there. There's a few other formulas I can give you as well for interior angles, but this is an important one. The reason you need to know that is you need to know, oh, the sum of all the angles inside this quadrilateral add up to 360. And you can actually write an equation. Okay, E plus 74 plus 110 plus 80 equals 360. And you can solve that for E.
Okay.
And so E is 96. But that's not our answer. That's just this other little angle inside here.
Right.
Angle 1, measure of angle 1 plus this other angle here, they're a linear pair, so they add up to 190. So you could write yet another equation. Measure of angle 1 plus 96 degrees equals 180. And so when you solve that by subtracting 96 from both sides, the measure of angle 1 is 84 degrees.
Got it.
All right. Is this for homework, by the way, or are these just for us to kind of work through to talk about, or?
Yeah, just to work through. They're not homework.
Okay. Got it. Okay. So another way to kind of look at these problems that might be helpful. It is always a good idea to just substitute the numbers in wherever you have for the angles, but it's to go to the thing you're trying to find right away and be like, all right, find measure of angle E. There's angle E right there. And you literally ask the question, what do I need to know to find, letter E or angle E? And I think that's an important question because it maybe helps you to say, oh, well, if I had all the other angles, I could find letter E. Now, maybe in the previous example is a little bit better. It's like, oh, to find measure of angle 1, if I knew this other angle, I could find measure of angle 1. And then you say, well, what do I need to find that angle? And it leads you to a place where you can actually find the information. But here they give you all the other angles. So, I mean, why wouldn't you throw these in here? So angle B is 50, C is 140, D is 150, and E we'll just call letter E.
Right.
All right, so this is a 5-sided shape. This is a pentagon. So we know that n equals 5 sides. And so you need to find the sum of the interior angles. That's n minus 2 times 180. And are you normally allowed a calculator on these tests?
Yes.
Okay. Will you calculate that sum for us and then?
Yes. Um, 540.
540. Yeah. So that means they all have to add up inside here to 540. The interior angles add up to 540. So that leads you to an equation. It leads you to, okay, it's E plus 160 plus 50 plus 140 plus 150 equals 540. So will you solve that for angle E, please?
Yes. Um, 40.
Yes. Measure of angle E is 40 degrees. Very good. Okay. I really need to give you the other formulas, but I guess we'll just keep working through these problems, and maybe the next problem or two here you'll need it or not. The letter A problems, I think you've figured out by now. They're pretty straightforward here for us. All right, yeah. So let's look at this problem here. Switch into number 4, but I thought we already did a 4, maybe.
They're from different. I took pictures of assignments from different homeworks that were like the review that my teacher
Okay,
gave us.
got it. Okay. All right. So this problem here, like what I noticed right away is there's kind of a big triangle. G, H, J, and then there's that little triangle inside there, H, J, M. And so like the only thing we can label here is that the measure of angle G is 50. So that's 50 right there. All right, and then we actually have nothing else, which is not all that helpful here, but we'll see where we go. All we know is that the angles are equal. So like if I call H X, then we know that this angle over here, the big angle, is 2 of them. It's X and X. It's actually 2X.
Right.
Okay, and then over here on the right, we can call this one Y. I don't know why I did that. We call it Y. So that's like that Y there. So then the whole thing is 2Y.
Right.
All right, so on the left, we can write an equation. We can say that 50 plus 2x plus 2y equals 180.
Right.
And then this other one on the right here, we don't know m, so I guess I'll just call it m. We can go x plus y plus m equals 180.
Okay.
Now this is a problem because we've got 2 equations but 3 variables.
Right.
So the only way, so this is where I almost want to see sample problem 3, because I'm guessing G and M are congruent, but I don't know, could you look to problem 3? I don't want to just say that,
Yes, I'll check.
because the other way is to write another equation or prove the triangle's congruent, which we really don't want to do if we don't have to. And actually, I should probably get my copy of the book out. I can help you find it as well. Geometry for enjoyment. So you're in chapter 8.
7. This was
7.
I think this one is from 7.1.
Okay. And then it says to see example 3, problem 3. Yeah, I'm looking at it now here. Let me pull it up here so I can show you. All right, so let's go look at this problem here together to help provide some explanation. So it's really similar to our problem here. So they do the this first equation right here is like the first equation we wrote here.
Right.
So we got that. Now what they're doing here is they're just subtracting 80 from both sides, get it down to 100, and they're dividing by 2, but that's not very helpful. So now they make this sort of leap. They say, okay, they write the equation we have, but they use this substitution. So let me show you that here. That probably doesn't make much sense. So let me show you that here. So this is correct here, the way we have it written. So on the left here, let's subtract 50 from both sides. So it's 2x plus 2y equals 130. Divide both sides by 2. So you have x plus y equals 65 on the left here. X plus y equals 65. So what they're saying is you can actually substitute in for the sum. You don't have to find the individual variables. And that's kind of a thing. That's kind of a thing you see in SAT stuff where you don't necessarily solve for x, you solve for 2x, or you solve for 5x, or something like that. And it allows you not to find x or y, but to find the other thing that you're looking for.
Okay.
So I would probably somehow put this down in your note card to sort of indicate that you may substitute for a sum rather than the actual variables, because it may not be clear what to do here.
Got it. Got it.
Okay. So 16 is related, kind of. Actually, I take that back. It's kind of related. Okay, we'll look at 16 next. All right, so here we go. Kind of another kind of these like overlapping triangles. So I would draw the big one, label it A, B, C, draw the little one, roughly to scale as best you can, B, D, C, like that. Draw the congruences, those still apply. And then start labeling stuff that you see that's given. So like angle A is 30. And it says that CD, ray CD bisects ACB. So it's essentially the same picture we had in the previous problem. These two angles are congruent. BD is one of the trisectors of angle. So that's a little different. It's saying that BD trisects angle ABC. So what that means is, how do I say this? Like a trisector means, let's think of a 90-degree angle. A trisector means that 30, 30, and 30. That's a trisector. So if we don't know the big angle, we have to call these X, X, and X. So if you don't know the angle and it's a trisector, one of them is X and the other is 2X. It's double the other one.
Right. Okay.
So down here, like we're gonna label, like, call this X degrees for BDC. I'm sorry, DBC. Well, that's why, because I've mislabeled this. Sorry, if you ever see an error, please let me know. D to B to C. And then the angle ABC is double it. It's 2X over here.
Okay.
Is that okay?
Yes.
All right. Is that right? No. I'm sorry. That's the mistake. That is the mistake. So B is the whole angle. B is the whole angle. So it's the two angles together, which is 2X plus X, or 3X.
Okay.
Like this is X and this is 2X. So when you combine them, it must be 3X.
Okay, right.
This one's got a few little wrinkles in it that's just makes it, awful. Totally awful. Okay. Now, this angle in the little triangle, if we call that Y, for example, Y degrees, then the whole thing, the whole angle here where C is, it's two of the Y's, it's 2Y.
Okay.
Is there anything I've said so far that you would like me to go over again to clarify?
Y is B 3x and C is 2y.
Yeah, I figured you were gonna ask that. That's we should look at this one more time here together. So let's why am I doing that? Let me snip in the triangle again, just the triangle. All right. Okay, so it says in the givens, start the givens, CD bisects ACB. So that means that this right here is congruent to this right here. That's the second given. Is that okay?
Yes.
All right. So if we call them X, this is also X. So what does the whole thing add up to?
2x.
2X, yeah. Now, in terms of those triangles, I'm going to draw those off to the right here. So this one, the smaller one is X, but the big one is 2X.
Okay, got it. Yeah.
Now the trisecting is just a tiny bit more complicated because what they're missing is the other angle here. And I used the wrong variable. I apologize. Let me change this all to Y's. I'm so sorry. Okay. Y, 2Y, Y, and 2Y. Okay. So now the third given is that BD trisects, or it's one of the trisectors of this big angle. So that means there's another trisector here that we don't have drawn. And if they're
Okay.
all X, like this, then they add up to 3X for the whole thing. But for the BDC, it's just X.
Okay. Right, got it.
Okay. Is that okay? Better now?
Yes.
And they give you that the measure of angle A is 30.
Okay.
So now we have enough to write two equations, one for the first triangle and one for the second triangle.
Okay.
So for the first triangle, it's the 30 plus the 3X plus the 2Y equals 180. So I'm going to write that. That's from the first triangle. That comes from down here.
Okay.
For the second triangle, it's D plus X plus Y equals 180.
Okay.
Now, the issue in this problem, which is what I actually thought we were going to run into in the last one, is that you cannot solve this one on the left for X plus Y. It's just not possible.
Right.
Or it's so complicated, you would never do it kind of thing. Just impossible here. So you might think we're stuck. But there's one more piece of really important information that they're not kind of showing you, or that it's almost hidden from you until the end. What kind of triangle is this if the two sides are congruent?
Isosceles.
And if the sides are the congruent, what do you know about the base angles in an isosceles?
Also congruent.
Yeah, so that means that 3X equals 2Y. So that's our third equation, 3X equals 2Y.
Okay.
You might think, why is that? How does that even help us here? I mean, you don't want to solve a system of equations. No, absolutely. You don't want to do that. But this 2Y can go in for the 3X. So it becomes 30 plus 2Y plus 2Y equals 180. And if you don't like that, you can substitute in the 3X for the 2Y.
Okay.
That's probably not, you probably haven't seen this very often.
No.
Okay, and we can do a few other problems to get you a little more comfort with that. I actually pull up some SAT stuff, but is that okay, or do you want more explanation on that?
No, that's okay. That makes sense.
Okay, so notice we're down to one variable. If you subtract the 30 from both sides and combine the y's, you have 4y equals 150. Divide by 4. So y equals 37.5.
Okay.
You're like, oh, that doesn't feel very good. Yeah, you're right. It really is not. But you can use that back in this equation to solve for x. So we have 3x equals 2y. You can take that number and put it in for y. So 3x equals 2 times 37.5, which is 75. And then x equals 25 because you divide both sides by 3.
Okay. Okay.
So now why do we do all that? Because we really want to find angle D. So we need the value of x and we need the value of y. We know that x is 25 and y is 37.5. And we can solve that for letter D. So it doesn't work out nice. Like we're used to these working out nice, but they don't.
No.
All right, so any questions on this? Let's see, D is whatever it is, 62.5. So what was that? 117.5 degrees.
No question.
Okay, so let's just quickly talk about this substitution stuff because I agree it's really, really awkward. Let's say that x plus y equals 5 and m plus x plus y equals 12. Okay, you can always do this where you take this and replace the x plus y with 5. Okay, but let me show you why that works, because I think that's what's unclear. It's like, well, does it just work for this one problem or does it always work? Let's solve for y. Y equals 5 minus x. Okay, and that's because that's what you're more comfortable doing. So let's put that in for y. So it's m plus x plus 5 minus x equals 12. Do you see how there's an x and a minus x here?
Yes.
They cancel. So notice you get the 5 anyway.
Right.
And that's the idea. The idea is like, well, you could do the substitution, and probably you should. But if you can see it, then maybe you don't. You get to save a little time here. And then you subtract 5 from both sides and you get m equals 7.
Right. Okay. Yeah, that makes sense.
Okay, now does it work for, does like what Matthew just said, well, does that work for this one right here? So let's take another look at this one. So it was 3x equals 2y. Okay, so let's just solve this for y. Divide both sides by 2 and y equals 2/3 x. Okay, and that's not great, but it's like okay, well, that's what we're used to doing. So 30 plus 3x plus 2 times, did I do this right? Sorry, let me just go back up and look. 3x equals 2y. Is that what we said? Yeah, okay. There it is. Okay, sorry. It just the numbers aren't going to work out nicely. So y is really 2/3 x. Right, so you now have this awful fraction. It's 4/3 x equals 150 because you subtract 30 from both sides.
Yeah.
So you need to find a common denominator. So that means you multiply the top and bottom by 3. You get the 9x over 3 plus the 4/3 x, like that. So it's really 4x over 3.
Hmm.
Something about this just doesn't look right. Okay, so that's 13x over 3 equals 150.
Okay.
And this really, oh, it's 3/2 x. I'm sorry. That's why this was not working out very well. Why isn't it letting me grab that? Sorry, my screen is. So what I was trying to show you here is that if you try to solve for the variable, you end up making more work for yourself. And
Right.
if you could just like substitute in for the sum, or in the problem we just did for the for the 2y, it really goes a lot faster for you. Yeah,
Yeah.
it's like 5x plus 8y equals 1, and 8y equals negative 2x. Okay, it's way better if you just take that negative 2x and plug it in for 8y.
Yeah. Right.
And so you get 3x equals 1, divide by 3, x is 1/3. Rather than,
Right.
oh,
Okay.
y is negative 2x over 8, and now you're plugging that in here. It works. It just doesn't create this nice numbers that sometimes you can get some really bad fractions as a result of all that.
Right.
Okay. Let me see here. I believe that is everything. Now we got some time left. We can even go. We'll go past. We can go even up to the hour if you've got some more problems you need us to look at for the test here. I can also find some. And actually, I didn't give you all the formulas that you need for this that I usually are covered here. Do you do the chapter review problems
Yes.
for homework? Okay.
Oh, no, we didn't. He gave us a separate worksheet this time.
Okay. So the chapter summary, this book is so old, it doesn't really give you the ones that you need. But there's a couple of formulas you need. We already talked about one. The sum of the interior angles is n minus 2 times 180.
Right.
Okay. Now for a regular polygon, and do you understand what I mean by regular polygon?
Yes.
So equal sides, equal angles. Okay, the interior angle, I'm going to just call it x. The interior angle is n minus 2 times 180 divided by n. So this is, go ahead.
The bottom one is for a regular polygon,
Yes.
and then the top one is for interior angles.
No, the sum. This top one is for the sum. Sum of
Okay.
the interior angles.
Right. Okay.
So let me give you an example. Let's look at a triangle. All right, so for a triangle, n equals 3. Okay, so let's do the S here for this. So it's 3 minus 2 times 180.
Okay.
So that is 180. Is that okay?
Yes.
All right, now the interior angle x is the n minus 2 times 180 over n. So in your problem, it's 3 minus 2 times 180 over 3, which ends up being 180 over 3, which is 60. All right, so
Okay.
so if we go to our triangle again, what that means is that all the angles are the same. And yes, that's a regular polygon.
Right.
So we can do the same thing for like a pentagon's kind of probably the next reasonable one to do. So or a hexagon. Let's do a hexagon because that one will come up a lot in this class. So in a hexagon, there are 6 sides. And that's another thing you might want to write on your card or notes is like hexagon, 6 sides. Like an octagon is 8 sides.
Okay.
I think it's a septagon or heptagon. I can't remember. I'd have to look, but you may want to look those up because sometimes they will tease you in the test of like throwing that word out there and you got to decide, well, how many sides is it?
Right. Yeah.
So there's n equals 6 sides. So the sum of the interior angles is n minus 2 times 180, like that. So that's 6 minus 2 times 180, which ends, I'm sorry, times 180, not 1080. All right, I get tired too on the weekends. So that's 720. That means all the angles inside here add up to 720.
Okay.
But if we wanted an interior angle, we take the sum that we just found, the n minus 2 times 180, and we divide it by n. 6 minus 2 times 180 divided by 6 is the 720 divided by 6, which is 120.
Okay. Right. Makes sense.
Okay, now the exterior angle, the sum of the exterior angles, okay, so let's look at the triangles as our baseline. So these are all 60 in a regular polygon. The exterior angle here is 120. This exterior angle is 120. And let's go, well, I can't really go on the right. I got that one the wrong direction. Anyway, that one's 120 as well. So the 3 exterior angles add up to 360.
Okay.
Now let's look at a square. Square makes 90-degree angles. So what do the exterior angles look like here? Well, it's 90, 90, 90, and 90. What do they add up to?
360.
360. Notice these are the same.
Yes.
So the sum of the exterior angles is always 360 degrees. Always. That's another thing maybe to put on your note card.
Okay.
Now, to actually find that exterior angle, let's call it y. Y is the exterior angle. The formula is 360 over the number of sides. So remember how we were just looking at a hexagon
Yes.
and we said all the angles were 120?
Yes.
So the exterior angle must be 60. Do you agree with that?
Yes.
So if n equals 6, is 360 divided by 6 equal to 60? Yes. So this is another formula to know. There's sort of 4 formulas. So I'll make a table now for you. So there's the interior, and then there's the sum, and then there's the actual angle. And then there's the exterior, and then there's the sum, and then there's the actual angles. There's only 4 formulas. So the sum of the interior angles is n minus 2 times 180. The exterior angles is always 360. An interior angle is n minus 2 times 180 divided by n. And the exterior angle is 360 divided by n. And keep in mind, though, the angles are only for regular polygons. That's if they're all equal. The sum applies to any polygon.
Okay.
Do you have any other questions I can answer for you?
No, I think I'm good.
Fantastic. So I probably have to call it here. Apologize again for we had a little late start there, but I hope this helps. We normally meet on Tuesdays. I mean, that doesn't seem to make sense if you just had a test. Do you think you might want to meet tomorrow for a lesson?
I'm not. I don't know.
Okay, I'll communicate with your mom and see what she wants to do. But yeah, we'll hope this helps. Hopefully this helps on the test.
Yes, thank you.
All right, well, that is it for us for tonight. Thank you so much. I'll send you the notes here shortly, and I'll see you next time.
Okay, bye.
Bye.